Okay, so we've got a straight horizontal road, and you've got a cyclist on there, and it tells me total mass cyclist and bicycle 80 kilograms, so that'll be, the weight will be 80g. Resistance to motion, I'm going to put normal contact force in there, I don't know if I need it, I will. And resistance is 60 newtons, and she's pedaling, so she's going to have a driving force, that's her pedaling, I'll call it D. And no other forces, going at constant speed, so that will mean that the driving force must equal the 60 newtons. Anyhow, the question is, constantly working at a constant rate of 480 watts. So we've got power here. So as soon as I see power, I want to think I've got two things. I could get FV, or I could get work done divided by time. Okay, there's my two forces, the two equations, worthwhile writing them down. Here I've got to find the speed, so I've got to find the velocity at which you cycle. So I've got to find V. Pretty obviously, I'm going to choose the top one. First off, I need to find out, I need to know the force, so I need to resolve that way. And there's no acceleration, so I could put resultant force equals ma. I've got d minus 60 equals 0, so basically d equals 60. That tells me what I've got, and I've got power equals Fv. I now know that the force is 60, the power is, it says 480, so 480 equals 60 times by V, so V equals 480 divided by 60, which is 8 meters per second. So that's done the first part, 3 marks, and now the second part, do it here. Cyclist now instantaneously increases her power to 600, so bang, 600 watts. I'll write that down. After travelling this for 14.2 seconds, so we've got given some time, her speed reaches 9.4. So it was, U was initially 8, just the one I just worked out, and then it becomes 9.4. I've got to find the distance, so that will be, I'm going to put that as x, and put x equals question mark. As soon as I got that, I'm going to have something to do with a distance, and this equation here has got nothing to do with distance, so I'm going to have to be doing something with the second one, the work done. Okay, so I need to find out what the work done is. So I know that power equals the work done divided by the time. They told me it's 600, so 600 equals the work done divided by the time, which is 14.2, and so therefore the work done equals 600 times 14.2, that's 8,520 joules. So now I know what the work done is. I'm going to have to try and find out what's an equation for that, and I know that's work done by a cyclist is equal to the gain in energy, and that's what it would be if there's nothing coming out of it. But we've also got the resistance to motion, and that's going to take energy out of the system. So I've got to decide which way to put it on, and I'm going to want to put it down on the right hand side, so that'll be plus the work done against the resistance, or against friction, whatever you call it. So, work done by a cyclist, 8,520. Gain equals gain in energy. Well, the energy is going to be kinetic energy, and that equals 1/2 times the mass times by V squared. So it'll be 1/2 times the mass, which is 80, times by V squared, which would be 9.4 squared. That's what it was at the end. And I've got to take away 1/2 times 80 times by 8 squared. That's what it was at the beginning. And I've got to add the work done against that. And work done is a force times the distance. So the force is 60 because that's the resistance force, and the distance has got S. In this case, I've said it's going to be X. That will give us 60x equals 7545.6. So X equals 125.76 meters, or 126 meters, to 3 significant figures. And that's question 1 done.